Hey there, boys and girls. Hope you guys had a good Easter break. Here we are back at it. I'm actually doing this on the 15th, so I don't have to do it next week. So here we go. We're going to go through a couple lessons. Like I said before, um, I, I'm going to start cutting some of the content out that I would normally teach in the classroom. So as such, I'm going to be giving you guys, instead, for this week at least, instead of giving you 4 lessons, I'm going to give you 2 lessons. They're going to be a little longer lessons because I'm going to be combining a few sections, and then I'm going to give you the rest of the time to maybe work on some projects, your quizzes, those types of things. And we'll see how that goes for oncoming weeks. So today we're going to talk about topic 2.2 and 2.4, the law of reflection, or reflection with mirrors, and then refraction. Okay, so we're going to start with just talking about ray diagrams. I told you before, ray diagrams are used to show how light rays move from one spot to another. They can also be used to show how light reflects and refracts. This is pretty important. So if we are actually in the classroom, you'd be able to draw me some ray diagrams and those types of things. There are specific terms you need to know with these ray diagrams. So we would be doing a lab in this one. We're still going to be doing some sort of a lab, but because of these labs, you would have to know the different terms that are associated with these ray diagrams. I've done this a little differently, so this PowerPoint is going to be a little different than the one that I have on D2L. It should still have the same information, it's just going to be a little bit in a different order. Okay, so the ray diagrams. Right here on the side, I've got a ray diagram that's represented that represents reflection, and right down below we have refraction. And you can see right away just by looking at these, there's similarities and there's differences. We've got a ray coming in here, we've got a ray coming in here. We've got a ray on this one, on the reflection one, that bounces off. We've got a ray that on the refraction, it doesn't bounce, it goes through, but you can notice that maybe it bends a little bit. And in both of these, we have a line that is perpendicular to the surface where the ray of light actually hits. These are all very important terms. So we're going to go over each of these terms. Okay. So first, we're going to talk about reflection. Right here it says plane mirror. So the ray diagram for reflection, you typically draw a straight line, just like so, and you label it plane mirror. Since plane mirrors provide the clearest reflection, we'll be using those for our ray diagrams. We're not going to be worrying about the diffuse reflection that we talked about in the last section. The medium interface right down here, if you take a look, this line that goes across on the refraction, that represents the medium interface, or the interface between the two mediums. So up here we have a vacuum where there's no air, so all the air would be sucked out, and right here we have glass. Okay, there's, with all of the medium interfaces, they always divide 2 separate mediums. So it could be just like this, no air, a vacuum, and glass. It could be no air and air, could be glass and water, could be air and water, a whole bunch of different scenarios. Anything that goes through a transparent surface like this, the medium would be transparent, that has a different substance on each side. If you think back to Unit 1, one of the things that we can automatically go and think about these different mediums is the different densities. Vacuum would obviously have a different density than glass. Air would have a different density than water. So that's a very important thing to keep in mind. Let's move this up here. Next is the normal. The normal is a very, 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 very important part of the ray diagram, and you can't actually see it. The normal is an imaginary line, and it's this imaginary line right here that is always perpendicular to the interface. If you take a look on the reflection diagram, the normal is perpendicular to the mirror and it stops right at the mirror. If you take a look at the refraction, again, the normal is still perpendicular to where the interface is, but obviously it goes straight through. Okay, so the normal in this one, it divides the ray diagram in half, a left and a right. And in this one up here, it divides it into quadrants like a Cartesian plate. So we have a top right, a top left, a bottom right, and a bottom left. Very, very important. Okay, next for ray diagrams, we have the incident ray. The incident ray is the same on both ray diagram, or so both of these ray diagrams. So whether it's for reflection or refraction, and the incident ray is simply the ray of light that comes in, or the ray of light that is being shone at the mirror or the interface. The incident angle is the angle we would be measuring. So we would be measuring this in class. or on some labs. And the incident angle is always, always, always the angle between the ray and the normal. So it's this angle right here, okay? One of the biggest misconceptions or mistakes students make is they measure the angle right here. For reflection, not a big deal. We can figure it out. So we can figure out the difference. For refraction, it sort of screws things up, okay? So the incident angle or the angle of incidence is right here. As down here, we have the incident angle, the exact same angle. The reflected ray is something that's only on the or on the reflected mirror, and the reflected ray is the ray of light that bounces off due to the reflective surface. So this right here would be the reflected ray. Now, I said it's not down here. It only occurs when we're dealing with reflection. So that is true. It does not happen on it does not happen on refraction. However, if you keep on bending these rays of light down, eventually something called internal reflection happens, and the light will bounce off the surface. And you'll see a video, when I show the video on Snell's law, you'll see a little bit of internal reflection. Nothing to worry about though. We're not doing internal reflection in grade 8. More ray diagrams, the refracted ray. So down here we talk about the refracted ray, and that obviously occurs with the refraction diagram down here. And the refracted ray is the ray of light that goes through the medium, okay, and it is measured from the, it's the ray of light that goes through the medium. It's obviously only in refraction. We actually saw this when we did the light up your life demonstration, when we were shining the light through the glass jar with the baking soda in it. So you can see that the light bent. So it's the bent ray. The angle of reflection, very similar to the angle of incidence, is the angle that the reflected ray makes with the normal. So you can see it's right here. And again, very important that you measure it from the normal to the ray, to the line. And then the angle of refraction, again, same thing. It is the angle from the refracted ray to the normal. Very, very, very important to remember those. This one in class, we would have been measuring. This one, we wouldn't be. We'll be watching a video called Snell's Law. I'll post that for you. All right, I think it'll be on here. So this leads to the scientific law of reflection. Remember, we talked about laws earlier, and I told you guys you're going to try to disprove a law, even though it's not possible. Scientific law is a scientific fact. This is true 100% of the time. So the law of reflection states that the angle of incidence will always, always, always be the same as the angle of reflection. So this angle right here will always, always be equal to this angle here. This is true for all types of reflection, regardless of the type of mirror, whether it's a flat mirror, a plane mirror, a wavy mirror, a curved mirror, or the reflecting surface, whether it's diffuse reflection, whether it's not diffuse reflection. The angle of incidence is always the same as the angle of reflection. Now, we remember from the diffuse reflection, the rays bounce all over the place. They're going left, right, up, down. But you have to remember that the angle of incidence is always measured to the angle of relative to the normal. So even though it's bouncing all over the place, because it's relative to the normal, the angle of incidence will always equal the angle of reflection. That's a scientific law. Okay. Refraction is the process in which light is bent when it travels from one medium to another. We saw that in the light up your life demonstration. So the light bends. The light bends as it's changing speed when it moves through the materials that have different densities. You may remember this from the Bill Nye video. So as the light's moving, there's my hand. As the light's moving, it goes and it hits something, and the density is a little thicker or a little higher, so that it ends up by bending because it's hitting more particles. You can think of it as well as if you're marching in a long, long line, everybody's marching at the same speed. Now, one person at the end sort of slows down a little bit, and everybody else ends up by turning because of that one person sort of pivoting. That's how refraction occurs. The bending of light makes objects appear in a different position than they really are. We've seen this. You see this in your everyday life, maybe with a straw in a cup or a spoon in a cup, those types of things. So we got a quick video here that shows refraction happening. This is a very exciting video. So you can see we got a straw with some water, pouring the water in. This is so fascinating, guys. You're going to be amazed. Maybe I'm going to make you do a video on this that you're going to have to do on a Flipgrid. You never know. There we go. So you can see right here that the slow motion now. You see at the very end that you can, looks like the straw is in two different locations. You've probably seen this on your own at home. You can test this at home, take a cup and put a spoon or something in it, and you can see how it bends. Maybe some of you that swim, I know some of you are competitive swimmers, you throw a ring into the water, you dive down, you know you cannot dive right or dive as though you're looking at the ring. You have to dive into a different location because it won't be there, all because of refraction. Okay, so how light refracts? Light travels slower in material that is denser because there's more particles. Think of running down the hallway back a long, long time ago when we were in school and the bell goes. There's a lot of kids in the hallway. It's not as fast moving down the hallway because you're going to be bumping into a lot of kids. You're not able to get from one class to another as quickly because the number of kids. The same thing is true with light. Okay, so as the light's going through this vacuum, there's nothing interfering it. There's no air particles. But once it hits this glass, it starts to slow down because there's more particles. It's more dense. So because it's more dense, it ends up by bending inwards. Okay, this is why fish aren't where they actually appear, or this is why those rings where you're diving into the water to go catch those rings or to get those rings aren't where they appear. Okay, the actual fishy down here is actually a little bit lower than where the fish actually appears because the ray of light, as it's, remember uh, old Romer said, light bounces off an object and goes to your eye. The light that's bouncing off this fish is going to your eye. It's coming straight out here, but because it bends, the light you actually see is over here. So the fish actually appears to be higher than where it really is. So if you're spear fishing and you wanted to catch this fish, you wouldn't be throwing the spear at the fish. You'd have to be throwing it lower and in front of the fish in order to actually catch that fish. Uh-oh. What did I do? Oh, this is a video that's not going to play, so let me try to get out of this and go back to my PowerPoint. Where are you? Okay, so there will be a link to a video that shows refraction. It's pretty cool. Okay, so the law of refraction. The law of refraction states that when light travels from one medium, from one medium to a more dense medium, the light will be bent towards the normal. So as it goes from a medium that's more dense, it bends towards the normal. Very important, might be a test question. The opposite is true when it travels from a medium that is less dense to a medium that's more dense. It bends away from the normal. Okay, this new direction of light is called the angle of refraction, which we already went over. Okay, here is a video. I can't remember what this video is. Here's a video of Snell's law. I'm not going to watch the whole thing, but it's so exciting. Okay, calm yourselves down. It's really exciting. Look at that ray of light going right through. It's right through the normal, so you can see it goes straight through. There's no refraction occurring here. Goes in 5 degrees, comes out 5 degrees. Goes out in 10 degrees, comes out about 7.5. You're seeing refraction happen here. So we definitely see here as the light ray goes in, like you can see the incoming ray or the incident ray relative to the normal. Okay, out here it's just air. Up here it is lucite or glass or whatever it is. You can see that the refracted the angle of refraction is less than the angle of incidence. Okay. You're also seeing, if you take a close look right here, you can see a little bit of reflection. This is what I was talking about, the internal reflection. So this law just essentially is stating that the ray of light and the law of refraction, that the angle of refraction is less than the angle of incidence because this medium is denser. Let's fast forward a little bit just so you can see the angle of incidence a little better. Right there, sorry, not angle of incidence, you can see some internal reflection here. This angle right here and this angle, those are the same because that's a reflected ray, but obviously the refracted ray is different. Okay, that's it. It's not that exciting, but it shows it really well. Okay, so this leads to one of the last slides here, and it's a mirage. Some of you may have seen mirages before. Mirages aren't like those old-time cartoon shows or TV commercials where someone's in a desert and they're traveling through the desert for a long, long time, and they're starting to die of thirst, and the buzzards are flying over top of them, waiting for them to die because they eat them. And then you look way off in the distance and you see, oh my goodness, it's a 7-Up machine, or sorry, a Mountain Dew machine. So you get so excited, so you go running all the way to the Mountain Dew machine, and you get there and it's 7-Up. Right? That sucks. Like, you're not going to get 7-Up. You're going to keep on walking. That's not a mirage, obviously. Okay. But a mirage is when you actually are walking in a hot, hot desert and you look way, way up ahead and you maybe see water. It looks like the ground's a little bit wet. Okay. We actually see this. We can actually see this in our everyday lives in the summer when it's a little warmer. Okay. So refraction can also occur, oops, it shouldn't be appeared there, when light travels through air at different temperatures because the air is warm, because warm air is less dense than cold air. This is what causes refraction. The refraction of light through air is called a mirage. And here's a pretty picture. So here we have what looks like water, okay? Right here we have hot air. So think of sand. Sand collects heat. It absorbs heat really, really well. So the air right above the sand is going to be warm because that heat is going to radiate from the sand, and the little area above the sand is going to be nice and hot or nice and warm. But then, of course, as the air gets higher, it starts to cool down. So it is quite possible to have cool air and then hot air right underneath it because the hot air is radiating up from the sand. Okay. Because this happens, the light ray from the sky starts to bend or refract as it goes from the cold air to the warm air. And as it does that, it ends up by giving us an apparent image of a wet ground. We see this when we are driving. And this video is kind of loud, so let me turn it down. But here you go, you see a road where you're driving. I'm sure you've noticed this before. Up ahead here, it looks like it's really wet, kind of like an oil slick. As you're driving, as you're getting closer to it, it goes away. Why does it go away? Very bad music. Okay, so we're getting closer, we're getting closer. When I was a kid, I used to, try to time how long does it take until we get to this wet spot on the asphalt. We never ever reach it because it's not actually there. It's just a mirage. Okay, so the asphalt gets really, really, really hot. If you ever stepped on it with bare feet or whatnot, and the air, obviously, the air above the asphalt is also going to be quite hot. So the sun rays, as they're coming down, they're in the cool air up here, gets to the warmer air down here, which is less dense, so it causes it to bend, and that's why we see that wet appearance. So what happens when light strikes a surface? Here are some of the different things that can happen. We can either have absorption, reflection, or refraction. So absorption is where the light all absorbs right into it. Okay, this is an energy transformation, and the nature of the surface is typically rough, dark, opaque substances, and then some of the light can get reflected. Okay, so the light on this moisturizer, okay, some of the light, the green light, is reflected, but the rest of it gets absorbed. Reflection is when light bounces off. Typically, the nature of the surface is smooth and shiny, and some light also gets absorbed. So light is reflecting off of this as well, okay, but a lot of it is also getting absorbed. And then refraction travels through in a new direction. The light travels through, but it goes in a new direction. And this is when we have different transparent mediums, and some of the light does get reflected. That's it. So this is what we're going to do for assessments, okay? So I'm going to be demoing a lab. There will be a lab that I demo, and you're going to have to answer some questions on this, okay? It's most likely going to be a recorded demo that I have. I haven't created it yet, okay? That's going to be assessed as a lab. So one of our major assignments. It's not going to be overly crazy challenging, but I might ask you guys to come up with a very detailed procedure on how you would do. So I'll do the demonstration. You're going to have to put that demonstration into words on the procedure, and then you're going to have to answer some questions. Then we're going to do a Flipgrid assignment again. So far I've got two from the last assignment, and they're pretty exciting. So this one, I'd like you to make a creative Flipgrid that shows the law of reflection. Okay, get creative, pet lasers, paper strips, I don't care. Paper strips meaning, showing a ray of light coming in, a ray of light going out. Okay, and I also want you to show me refraction. Okay, things not where they should be, or mirages. Already talked about how you could take a cup and put a straw in it or something like that. Get creative. And then the video, no more than 5 minutes. Okay, don't stress out about this. No more than 5 minutes. So for the few that I've gotten for the last assignment, they were 2 minutes. They were perfect. Okay, that's what I want for this. And then lastly, the application questions. So that's it for topic 2.2 and 2.4. The next lesson is going to be topic 2.3 and 2.5, comparing curved mirrors and lenses. That is it. Have a great day, guys.